All right, everybody, we're back for another edition. Today, what we're going to do is we're going to be talking about some SAT problems, the no calculator section, rather, of the SAT, titled Heart of Algebra. So the Heart of Algebra kind of studies two main things from your SATs, right? So they study what linear equations are. So just in case if we forgot the form, they study when we have an equation presented in this way, right? Y equals mx plus b, where we know m is the slope, right? And then b is the y-intercept. Okay, and then they also focus pretty heavy on system of equations, right? So, that's just an equation with two or more variables, right? And an order pair that works for both of them. So sometimes they're presented like this: 3x plus 6y equals 18. All right, so they can be presented in either way. And what you're doing is you're looking for an ordered pair that will work for both. Okay, so it needs to be an ordered pair that will suffice for both of those. All right, so what we're going to do is we're going to be looking at a couple examples that have to deal with this. So let's go down on the board. Okay, so first example we're going to look at is a pretty straightforward one. They're saying if 5 times x plus 6 equals 10, what is the value of 10x plus 3? So the first most important thing is let's just figure out the value of x, right? So you could say, okay, 5x plus 6 equals 10. All right, so we know we can subtract 6 from both sides here. Equals 4. And then let's say we divided both sides by 5. X equals 4 over 5. Or you could say x equals 0.8. Right, now generally I would work with the 4 over 5 just so I can reduce the fraction. So now that we know we have 4 over 5, we're going to go ahead and plug it in for this value of x right here. So let's say if we plugged it into that equation, we said, okay, this is 10 times, well, we're going to go ahead and plug back in our 4 over 5 plus 3. So let's say if we were multiplying these two, well, we could consider this as 10 over 1, right? So then from here, now let's kind of determine what are our cross products. So we know that this is cross product between 10 and 5 is just 5. So I can cross this out, make this 1. This will be 2 up top. So this becomes 2 times 4, which is 8. 1 times 1 is 1. So 8 plus 11. Boom, this gives us, 8 plus 3, gives us 11. So, that's our answer for the second one. Okay, so that one's pretty straightforward, right? So we're going to keep moving, all right? Okay, this one here, this one is more like a system, okay? You're dealing with a system because you got two equations and you want to kind of see what point satisfies both of them. So this is the no calculator section. So I understand that like time is at a premium, right? Like, time isn't necessarily working in your favor. So with this being said, the easiest way you could probably do this is just kind of look at your points and plug them in, right? So let's say if I was looking at letter A, right? We try to say, okay, 3 plus a negative 2 equals 0. Well, we see that doesn't work out because that just gives us 1 equals 0, right? And that doesn't work for us. So we know we can cross out letter A, right? Let's say if we are talking about letter B here, right? Let's say if we're talking about letter B. Well, letter B, I'll just kind of put it under this portion here. Letter B, we could say this is 2, right, plus a negative 2 equals 0. Well, that kind of checks out, right? Because 2 plus negative 2 here, that's just going to give us 0. So 0 equals 0. Okay, so that works, right? That worked for the first one. So let's see if we can check it off for the second equation. All right, so over here, let's say this is 3 times 2 up front because our x value is 2. minus 2 times negative 2. And that should be equivalent to 10. Okay, so let's say we try this out, right? So this is going to give us what, 6. Negative 2 times negative 2 is a positive 4. So we'll say plus 4 equals 10. Well, does that check out? Well, 6 plus 4 equals 10. So 10 equals 10. So remember, with a system of equations, it has to satisfy both. Okay, so letter B actually checks out. That's going to be our answer here. Now, what you could do essentially, if you wanted to kind of just check your other answers, reason why C wouldn't work, it does work for the first one, negative 2 plus plus a negative 2, sorry. We're just verifying why C wouldn't work. So negative 2 plus 2 equals 0. Well, it does check out for the first one, right? So it checks out for the first equation. But let's say if we tried the second one. So 3 times negative 2, right, minus 2 times 2 equals 10. So let's say if we try to do it with the second one, this is what, negative 6 minus 4 equals 10. Well, this is negative 10 actually, right? So since these aren't equivalent, that's why you couldn't use C. And for D, pretty much the same purpose, right? Your signs wouldn't match up. So your most appropriate answer choice is going to be B in this case. All right, so we're talking about this point here, right? We are saying in the XY plane above L, right? So let's call this first one L, right? L is parallel to line K. So now it's just asking us in this case, what is the value of P, right? What is the value of P? So we're looking for this value here. So, well, when we know we have parallel lines, what do we know about the slopes? Well, the slopes, right? The slopes are equal. Okay, so we know that the slopes are equal. So what I could do is I can pretty much say, okay, let's find, right? I can find the slope of line L. Right, I can find the slope of line L and potentially use that to kind of use my rise over run. So let's say if I was looking at line L and we could just kind of make our slope triangles right here. Well, we know that our slope is always our delta y, or a change in y, over the change in x. So let's say if we were looking at how many y units. So we're just comparing our y coordinates. So it looks like we went up 2 units, right? So we have a 2 up top, and going from -5, right? Going from -5 going to 0, looks like we moved over about 5 units. And as you can see, our slope is positive. So we know the slope here is 2 over 5. So we can say this is our slope, okay? We know our slope is 2 over 5. Okay, so now what we can kind of think about is looking at this version here with our second line, right? This line down here, right, with line K. Okay, so now we're going to try to apply that same concept with line K. So let's say if I actually just use the orange here, right? So in this case, let's say if I use the same concept, right? So we still know it's our change in y over the change in x. Well, in this particular case, it looks like in order for, we know our slope needs to be 2 over 5. So we could kind of set this up using a proportion, right? Couldn't you say, okay, this is 2 over 5 is going to be equivalent to, well, what's our change in y? Well, it looks like we went from -4 to 0, so we went up 4 units, right? And you could just put this over x and kind of use a proportion. So the quickest way you can kind of think about this, we know we had to multiply this by 2 to get to 4, so you'll probably have to multiply the bottom by 2, right? You could work it out a little bit longer, but this is just quicker, so you know that x will equal 10. And that makes sense because if you take 4 over 10 and you reduce it as your fraction, you know, just kind of showing the work why it works, it still gives us a 2 over 5 slope that we need, right? So we know the value of x needs to be equivalent to 10. All right, so looks like we're doing well so far. But you want to kind of just make sure that you understand all of your different ways of thinking, right? Just want. All right, so let's look at this example. They're saying in the system above, A and B are constants. If the system has infinite as many solutions, what is the value of A over B? Well, when we have a system that's IMS, right, or infinite many solutions, that means that everything is equal in the equation. So the slopes would be equal. And the y-intercept values. Okay, both of those would be equal for us. All right, so in this case, when they're saying what is the value of A over B, so the simplest way I would think of this is kind of look at the relationship between your constants, because your y-intercepts need to be the same and your slopes need to be the same. So let's say if we're going from 12 to 60, well, and let's say we just want to kind of figure out some type of relationship. So generally speaking, I would probably take 60, right, just divided by 12, right, just to kind of see if there's some type of relationship. Well, when I do that, I get 5, right? I know 12 times 5 will give us 60. So I know that I multiply this by 5 to get that relationship. So that's one thing I know about this. The second thing I know is I can figure out what A over B is of this bottom equation first, right? So let's go ahead and we figured out what A over B is of the bottom equation, right? So A represents your X value, right? So we know A equals our X, B equals your Y. So A over B for this bottom equation here would just be 2 over 8, which simplifies to 1 over 4. Okay, so I know that what I know is this second equation is 5 times larger, right, than the first equation, because just kind of looking at that value, the second equation is 5 times larger than the first equation. So now they're asking if the system has infinite as many solutions, what is the value of A over B? Well, I actually don't have to go any further because we know our slopes are always going to be kind of equivalent, right? So even if I was to kind of solve for this, and I'm going to prove that's why it's going to always be 1 over 4. So let's say if we took this one here, well, we know that this, since we multiplied by 5 to get to 60, let's divide by 5 to get our other numbers, right? So technically that second equation, right? Couldn't we say this first equation rather, I'm sorry, this first equation highlighted under in green. Well, what's 2 divided by 5 is 2 over 5x, right? And then we're going to plus, well, what's 8 divided by 5? Let's just leave it as a fraction, 8 over 5. Y equals 12. Okay, so just to verify that this is always going to be 1 over 4, let's divide these two, right? So let's say if we had 2 over 5 being divided by 8 over 5, well, we know we have to multiply by the reciprocal. 2 over 5 times 5 over 8. Well, let's look at any cross products we can simplify out. So I know that 5 can go into itself one time, so that's 1. This is 1. I also know 2 can go into both itself and 8, so we can make this 1. This is 4. So when we multiply it out, 1 over 4. So you didn't necessarily have to do the second part, but I was just verifying that this works. If you found this helpful, please like, comment, or subscribe to the channel. Give us any content or any particular type of problems that you would like to solve, right? We're here to help. So, please support your boy. I appreciate it.